All right, what we're going to be looking at now is a matrix question, right? Matrices question. This is a 2007 matrices question in paper 2, CXC. It says here, given that D is equal to 1, 9P, P4 is a singular matrix, determining the values of P. You notice it did say values of P, which is suggesting that I'm going to be having more than one. All right, what does a singular matrix really mean? All right, so that's the key thing, understanding the idea behind a singular matrix. A singular matrix is a matrix which the determinant is equal to 0. For example, if this is a matrix A, and it is A, B, C, D, if this is a singular matrix, then the determinant, which is the product of the leading diagonal, determinant A, which is the product of the leading diagonal, subtract the product of the non-leading diagonal, this should equal to 0. So the concept of the singular matrix is such that the determinant must be equal to 0. We want to use that idea to help us to solve this. So here it is. Here is the leading diagonal. And here is my non-leading diagonal. So let's go. The determinant of D, which is 1 times 4 minus P times 9P, this should give us 0. Well, let's continue. 1 times 4 is 4, minus P times 9P is 9P squared. This is equal to 0. But why not just gather the P's on the right side, let it becomes positive, which means I'm going to be adding 9P squared to both sides. So finally, 4 is equal to 9P squared. Then I'll divide by 9. So then we could see here that 4 over 9 is equal to P squared. Then I'm going to take the square root off. So taking the square root of the P so that the P squared, so that we could have P alone, would have to take the square root on this side, which means that I'm going to have a plus or a minus. So basically then, if you're taking the square root of a fraction and we have perfect squares under there, you actually can take the square root, which means we could go deeper. What do we mean? It simply means then that what we have here is the same as taking the root of 4 over taking the root of 9. And that's going to give us P. All right? Remember, it's always a plus or a minus of the idea. So what are we getting here? We're getting here a plus or minus 2/3 is equal to P, which means that in reality, there is a positive 2/3 that is equal to P, and there's a negative 2/3 that is equal to P. That's what. All right. Now let's look at this other question. Write the equations in the form AX equal B, where A, X, and B are matrices. 2 marks to do that. So we're expected to put these in a matrix format. So the coefficients are what we're going to be picking on early. The coefficients will go in a matrix for itself. So we have a 2, a 5, 3, 4. And then we have X and Y here. And this is equal to 6 and 8. So this is the matrix format, A, X, and B. And we would have gotten those 2 marks for that. Calculate the determinant of the matrix A. So now we want to find the determinant of the matrix A, 3, 4. So determinant is going to equal to 2 times 4, which is the product of the leading diagonal, minus 3 times 5, the product of the non-leading diagonal. We're looking at 8 minus 15, which is equal to -7. So that's the determinant of A. The determinant of A is equal to -7. Question went further to say, show that the inverse of A. So now we want to show that the inverse of A is -4, 7, 5, 7, 3, 7, and -2, 7. To find the inverse of A, so the inverse of A is 1 over the determinant of A times the adjoint A. So now we have found the determinant of already, so it's 1, -7. And we want to multiply that by the adjoint, but the adjoint of the matrix would suggest that we're going to be switching the elements, swapping the elements on the main diagonal. So when you swap, the 4 goes where the 2 is and the 2 comes where the 4 is. And then we're going to be changing the signs of the elements on the non-leading. So the +5 becomes -5 and the +3 becomes -3. This in itself is the inverse, but we need to show it in a simpler form. So it simply means then we're going to multiply everything inside the matrix by 1 over -7, which is going to leave us with -4, 7. Then when the -5 and the -7 clashes, we'll end up with a +5 over 7. So when we multiply the -17 by -3, similar thing will happen like this one. So we're going to have a positive, the 2 negatives will cancel. So we'll have a +3/7. And when the -1/7 is multiplied by 2, we'll end up with a -2/7. And then this is the inverse, which is exactly like what they wanted us to show there. So we're seeing that we have shown that, right? So it's exactly what they wanted us to show right there. All right. Let's go to the final piece of the action. So the last question says, use the matrix, use the inverse of the matrix to solve for X and Y. So let's see if we could get back these here. So we're asked to use the inverse to solve. So we're asked to use the inverse to solve. So whenever you're using the inverse to solve, all we're going to do is that to understand what really happened. So let me just quickly explain what happened. AX equal B. Whenever the inverse of a matrix is multiplied by the matrix, it becomes the identity matrix. The identity matrix times X will leave X because that's what the identity matrix does. The identity matrix is 1, 0, 0, 1. So if you use this matrix to multiply by anything, that thing remains the same. Therefore, putting the inverse in front of A would give us the identity. The identity times X will still leave all of this here. So it means then we could just write this back here. And then now, whatever you do on one side, you have to do it to the other side. We have to put the inverse in front of the B, so we're going to have to carry out this. So let us write the inverse here. -4, 7, +5, 7, +3, 7, -2, 7. So this is the inverse matrix. And And then we're going to be using that to multiply by 6, 8. And then after that, we are good. Remember, when we multiply, it's row by column, or some people say across down. All right. So we're talking about row by column. So let me highlight my rows. So that's row 1, and this is row 2. And let me highlight my column. This is column 1. So I'm going to use row 1. Could I just put it here? Row 1, row 2 to multiply by my column 1. So it's only one column. So it's row by column. Row by column. So let's go. So -4, 7 times 6 plus 5, 7 times 8. That's my first move there. Secondly, I'll have 3, 7 times 6 plus -2, 7 times 8. Let's break this down, go further. So what are we looking at? We're looking at -24 plus 40 over 7, and then 18 minus 16 over 7. Finally, what we have, x, y, is going to equal to 16 over 7, 2 over 7, which means x is equal to 16 over 7, and y is equal to 2 over 7.